We're going to practice balancing equations today, and I'm going to show you a very easy way to break it down, make it super easy for you to do. You might not always need to do it this way, but occasionally you may get to a more complicated equation that needs to be balanced, and you might find yourself falling back to this method. All right, so we start with the equation, and the first thing I'm going to do is I'm going to draw a line separating my work from my equation. You're going to need lots of scratch paper for this, so make sure you have some handy. All right, and then I'm also going to put a line going perpendicular where my yield or arrow is on my equation to separate the two sides of the equation. Now you have to remember the reason we balance equations is because the conservation of mass states that you have to have equal mass on both sides of your equation, and this is going to help you achieve that by manipulating the formula. All right, so the first thing we do is we're going to take our first formula here, nitrogen, and we're going to separate it into what it should look like if it was separated out. So not N2 anymore, but actually NN. The same goes for hydrogen. Write it out in longhand version. Okay, then we're going to go to the other side of the equation, and here I have one N, and I have 3 hydrogens. Now, notice that I kept these together as a unit because this is a compound that needs to be kept together. These two were separated by a positive, or an addition sign, so we're going to separate them while we're doing our work. It's really important that you keep those compounds connected together. All right, so now we're going to count how many we have for each atom on each side. So I look at nitrogen, and I have 1, 2 on this side, and I go to my other side because it has to be equal, and I only have 1. So I need 1 more. So anytime I add something, it's going to be down below. So I have 1 nitrogen. However, that was a compound, so everything that was with it, you have to rewrite as well. All right, so my nitrogens are equal. So I have 1, 2. Now I have 1, 2. So let's see how our hydrogens are. I have 1, 2, but on this side I have 1, 2, 3, 4, 5, 6. They're not equal, so I need 6 on both sides. Here I have 2, so I'm going to add 4 more. And notice, these are connected together. They have to stay together, and every time I add 1, I have to go to the next line. So here I have 1, 2, 3, 4, 5, 6 total. Before I think I'm done, I always go back and I double check. I have 1, 2 nitrogens, 1, 2 nitrogens, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens. So the work is complete, but I'm not done with my problem yet. Now what I'm going to do is I'm going to circle how many lines I've added. And this one there's only 1 line. So this would be a 1, but we normally don't write 1. It's just a given if it's blank, so I'm going to erase that. Here I have 1, 2, 3 lines. So there's a 3 that goes in that space. And here I have 2 lines that were added. So now, looking at my equation, I have a 1 here, a 3 here, and a 2 here, and it will work every time. Let's try another one that's a little more complicated. I start with drawing my line to separate my work. I draw a perpendicular line under my arrow. It wasn't very straight, but it serves its purpose. And then I'm going to rewrite the entire equation longhand. All right, so I'm going to start here with CF4. So I have C and I have 4F. And here I have Br, which is bromine, and I have two of them. So I'm going to write it twice. Let's jump to the other side. Here I have one C and I have 4 bromines, and I have to keep them connected. And then I go to F2, so I write it FF in longhand. All right, so now I'm going to go and count them. I'm going to change the color to 10. So I have one carbon, I have one carbon. So far, so good. I have 1, 2, 3, 4 fluorine. Over here, I only have 2, and I need to have them equal. So that's an easy fix. We just add 2 more. So now my fluorines are equal. Here I have 2 bromines, and I have 1, 2, 3, 4 on this side, and they have to be equal. So when I add them to this side, it equals out. I think I'm done, but I'm going to go back and double check. 1 carbon, 1 carbon, 4 fluorine, 4 fluorine, 4 bromine, 4 bromine. So that one isn't as difficult as it initially appeared. So now I circle how many lines do I have. I only have 1 here, so I'm going to leave that blank. That just indicates that 1 is given. I had to add a line, so now I ended up with 2 lines here. So I'll write a 2 in the space before bromine. I just had 1 of these and 2 of these. Okay? All right, I'm going to do another one. Some of them you can have a little shortcut. Draw my lines to start out. Okay, now I'm going to rewrite it in longhand just like I did before. So I'm going to rewrite this. And I could write it AgNOOO if I want, but I recognize this as nitrate. It's a polyatomic ion. With polyatomic ions, if they stay together on the other side of the equation, then you don't have to write those out longhand. You'll just treat those as a separate ion in itself. So if I look over on this side, I do notice that NO3 or nitrate does stay together on the other side. So I'm simply going to write it NO3. And I'm going to count this as its own unit. Then I write my copper. There's only 1 of those. Here I have 1 copper, but notice I have 2 nitrates. So I'm going to write it out twice. Because remember, I said I'm treating nitrate as its own unit. And then I have 1 silver over here. Okay, so now it's written out longhand. Let's start counting. So I have 1 silver. I have 1 silver. I have 1 nitrate. But here I have 2 nitrates. So I need to add a nitrate over here. But remember, this is a compound, so the silver has to come down with it. Okay? I have 1 copper. I have 1 copper. Now I'm going to recheck because when I added the nitrate here, I also added another silver. So now I have 2 silvers, and I only have 1 over here. So I'm going to add another one. So I have 1, 2, 1, 2. So those are equal now. I have 2 nitrates, 1, 2 nitrates, 1 copper, 1 copper. So I'm done. So now how many lines do I have? For this one I had 2. For this one I have 1, so we leave it blank. This one I have 1, we leave it blank. And that one I have 2. Now you get the same result if you took the nitrate and separated it out, NOOO, but it's a little easier and just a little tip to make it give you a shortcut when you're dealing with polyatomic ions.